So this section will be primarily focused on introducing the topic of machine learning, some of the difficulties, some of the approaches, the different methods, different applications, etc. And we'll start applying some of this in the following sections. So contrary to popular belief, right, as a data scientist, you won't be spending too much time doing machine learning. A lot of your time will be spent acquiring data, building systems and pipelines and processes for, the acquisition of data, its cleaning up, its storage, its maintenance and all of that. And let me also add to that, reporting, building systems for presenting your work or giving access to it. This could be in the form of an API or a Shiny app or an R Markdown report or whatever it may be. So a lot of time is spent up, in the steps up to, an actual machine learning task and following it, right? So, building the systems, the pipelines, cleaning the data, acquiring it, all of that is before you get a chance to apply any machine learning to a project. And then once you actually do apply machine learning and you do get your results, there are a lot of steps that follow that as well, right? You need to make your results accessible. You need to make it applicable, right? You can come up with a very nice, model, but if your client or your company can't actually use this in production or use this live, right, as new data comes in, or they can't use it to make decisions, they're not easily able to access that model or to run it or to use it, then, there's really no point in everything you did. So there are a lot of steps following and preceding machine learning itself that will take up most of your time as data scientist, unless you do find that odd job here and there, maybe at some bigger companies where they have other people to take care of those steps, and you're just hired as like a machine learning engineer or something, and you just focus your time on applying the raw machine learning to a data set that's already been cleaned and all of that by some another team. But nowadays, we're seeing a transition into single man parades, if you will, like where companies are expecting a single, individual to be able to do most of this work. And that's something that's actually, it's not an exaggerated expectation. It's very plausible. It's very, in my opinion, very normal to expect that from a data scientist. And the reason for that is because machine learning has gotten so much easier to implement by the average layman. See, before, machine learning could only be implemented by people who had very high level knowledge in mathematics and statistics, and they knew the topic, academically very well. So, they would most probably have to be like PhD educated individuals, with a background in mathematics or statistics or something like that, or at least computer science. And so you couldn't expect of someone like that to also know how to deal with the more routine data acquisition, cleaning up, storage, databases, and that kind of stuff. So you would have a team that would deal with that. And then you would have your machine learning specialist building the actual models and that kind of stuff. But nowadays, machine learning has developed to the point where, you don't really need to have that much knowledge. You still need to know you need to have some basic understanding of statistics so you can interpret your results. But in terms of applying machine learning algorithms and models and training them, there are a lot of amazing libraries out there, like the library we're going to be using here, the Tidy Models set of packages, or in Python, you have scikit-learn, etc., that really make that stuff easy for you so you can actually focus on developing your skills across the stack. So, and companies are also starting to realize that it's not very sustainable to employ a whole team of data scientists. So a lot of companies are starting to actually outsource all their data science work to contractors or external consultants. So, that's a potential career for you, right? To be a consultant, or you can call yourself a data professional or a data strategy consultant or something of that sort. And so you would be expected to at least be familiar enough with the stack to where you could, if needed, outsource some of that work. But from the company's perspective, the company that's hiring you, you're the one that's doing the whole project from beginning to end. And in those rare situations where you really do need to have a machine learning expert, you can outsource that work as well. There are a lot of professors out there, experts in machine learning, they have hourly rates. You consult them on very fine details concerning certain machine learning algorithms when needed to. But again, that nowadays plays quite a small role in an actual data science project, because nowadays dealing with that big data, being able to like maintain it and to build data lakes, data marts, data bases, and that kind of stuff, and all of that also transitions kind of into DevOps. But DevOps itself has also been seeing a transition where now we have like machine learning ops, etc., etc. I'm not going to go into too many details, but I just want to give you the impression that it does make sense nowadays for data scientists to be familiar with the whole pipeline, the whole range of tools required to get a data set prepared before you can even do machine learning on it, and everything following it as well. So again, you don't need to worry too much about that. Just focus on mastering this course. If you really understand and master everything in this course, you will have that complete, full stack of tools to become a very proficient modern data scientist. So you don't have to worry about that too much. I just want to open your eyes a little bit to what's going on currently in the data world. So with that, let's get started with understanding what machine learning actually is. So I took this definition off of Wikipedia just to keep it consistent. There are a lot of different definitions of machine learning, and they might slightly change based on how long ago that particular article or whatever journal entry or whatever was written. But essentially, machine learning is the study of computer algorithms that improve through experience. And this experience is fed back into the algorithm as data. So essentially, data is collected and the machine learning algorithm is enhanced or improved or changed based on that experience, which in turn should result in a more improved performance and so on and so forth. And when you can automate this, where this happens automatically, that's essentially what machine learning is. And it is a subset of artificial intelligence. Artificial intelligence is a very large domain, a very large field. Machine learning is a specific part of that domain. And, there's a lot of misconception when it comes to the word artificial intelligence. But, that's why we're not going to define machine learning or artificial intelligence as being machine learning. But machine learning is generally accepted to be under the umbrella of AI. And basically, how machine learning works is that a machine learning algorithm builds a mathematical model based on sample data. And that sample data is called the training data set, or training data, keep it simple. And the aim is for the algorithm or the program written on, based on that algorithm to start being able to make predictions or decisions without being explicitly programmed to do so. So sort of being able to learn from that data and pull in patterns or certain understandings from that data that will allow it to make decisions that it wasn't explicitly programmed to do, right? And we're going to see a lot of examples of this in the future slides as well. This is kind of more of a theoretical definition. And when you use machine learning and apply it to business problems, it's generally known as predictive analytics. And this is actually something that's, been around for some time. Machine learning nowadays is a very flashy term to be throwing around, but the underlying principles in machine learning and a lot of core machine learning work that's done today is actually quite old. Before, it was referred to as statistical learning, because machine learning is essentially statistical methods for solving certain problems. And we're not going to get into too much of that theory in this course, but machine learning is a modern term for statistical learning or predictive analytics, essentially, okay? And we can differentiate between statistical learning and machine learning and deep learning. Deep learning is a whole nother field, and that's something that is pretty new in the sense that we haven't been able to use deep learning to really solve problems similar to the problems we're solving now previously. But we were able to do that using machine learning, but we didn't have as much data to work with. So previously, like statistical learning was used on smaller data sets, simple problems, even problems that, you could, essentially solve, by hand, by seeing the data set yourself and running some equations and coming to conclusions and that kind of stuff. But nowadays, we're able to apply machine learning to large data sets far larger than anything you'd be able to fathom or understand by just looking at the data.